Your method of transportation is your own.
So the sponsor is myself.
The sponsor's me. You're going with yourself.
So I express my permission for my child to travel by personal car with itself.
Yes. But your mom and dad have to sign off on that, even if you're 18.
I'm just filling it out.
Okay,
She
good.
gets mad if I give her forms to fill out that aren't filled out.
Okay.
Mom's lazy.
That's really mean to say.
Actually, she works all the time.
So that doesn't make her lazy,
Like a
does it?
terrible child.
So you're a terrible child for calling her lazy.
Figures.
Maybe we'll send her an apology.
Sometimes she doesn't make me dinner though because she's tired and sucks. I have to go buy dinner.
Okay, so let's discuss this chapter real quick, or the end of chapter 23, which is all about the evolution of populations. We had left off yesterday talking about stabilizing versus directional selection, the types of models. One other thing that I want to mention is something that kind of opposes natural selection a little bit, and that's called sexual selection. Excuse me. And this is natural selection for mating success. In this type of selection, there are two subsets or two types of this selection. There is intrasexual selection, and there is also intersexual selection. In the case of intrasexual selection, this is when you have a competition. For mates. Usually this is between males. And intersexual selection is going to be all about mate choice, which is usually that of females. And we could talk about, like different instances of this, but I really don't think we need to. Showiness of birds, of male birds with specific emphasis on their feathers. That's one thing. The last little bit to mention is something called heterozygote advantage. And this is a situation or a case in which the heterozygote, the intermediate form, is preferred. With heterozygotes, have a higher fitness. Than homozygotes. So yeah. I think the best example that I could think of would be sickle cell. Individuals that are big T, of course have sickle cell anemia. No, I'm sorry. I'm telling you wrong. Big T is actually normal. Big T, and little t would be sickle cell. Yeah. But big T, little t, the heterozygote form, has malaria resistance, and those individuals are essentially normal enough. Their blood cells are not, their hemoglobin is okay, I guess you could say. And big T would be normal. However, they're oftentimes getting malaria. So I should write maybe malaria prone. And people that are little t, they have sickle cell anemia, which of course would be negative for their hemoglobin, but they have complete malaria resistance. So you can see in this case, the heterozygote form would certainly be advantageous. Now, of course, we wouldn't really need that in the United States as much because malaria is really not an issue, but in Africa, you would find that heterozygotes would be most likely to survive. So when there's a baby born in Africa, and this probably shouldn't be as true now as it was in the past, but back in the day, if you will, to be born with big T, the baby doesn't have sickle cell anemia, but they have a high risk of getting malaria, contracting malaria, and that causing their death. If they're born with little t, they're going to have sickle cell anemia, which is a very, very negative thing because your blood cells can't carry oxygen correctly. So the intermediate form, where you kind of have some bad blood cells but some good ones, kind of half and half, and you have the malaria resistance, and that would be kind of the best case. So that's heterozygote advantage. Cool? Okay. So that's all of that, and let's kind of go into the next part, which is all about chapter 24 and the concept of the origin of species. When is your test? Friday. Do what? You gonna study?